So hey guys, welcome to our channel M-cad tutorials. This is the second part of the video series in which we are going to learn how to design a turbofan engine in Siemens Unigraphics NX software. If you are new to the channel, please click the subscribe button below and hit the bell icon to receive the notification for all our future videos. So without any further delay, let's get started. Go to File, select New, select the destination in which you want to save the file. After selecting, click OK. Rename your file. Okay. Now go to Sketch, select YZ plane. Select Profile feature from the tool menu. Now we will start drawing this geometry from coordinates 0, 57.5. Draw a line of length 7.5 mm in the vertical direction. Now go to positive x direction and draw a line of length 38 mm and then 85 mm in vertical direction. Now here draw a line of length 10 mm in the negative x direction. From here 45 mm in the vertical direction. Again 10 mm in the negative x, 12 mm in the positive y. Now draw a line of 40 mm length in positive x direction and 7 mm length in negative y. So as you can see, all the dimensions are relative to the previous point that we have drawn. So in this way it really saves up the time. While we are drawing the geometry, we are defining all the coordinates also. So we don't have to draw the geometry first and then define all the relations and dimensions to the geometry. Once completed, this geometry will be fully constrained. If you are having any difficulties following all these steps, once I complete this geometry, I will provide you with all the dimensions here on the screen. So you can just draw the geometry, taking as much time as you want. Let me just complete this geometry. This is the cross section of the compressor rings that we are modeling in this tutorial. Create a closed geometry to revolve this around the x-axis to create rings. That's why we have chosen an offset of 57.5 mm from starting coordinate, so that we can have clearance for the shaft in between these rings. Just close the geometry, select line, create a straight line from here, select vertical constraint. Okay, now close this ends. Now the geometry is complete. Now finish the sketch. Now we do select this extrude. We just clear all the dimensions for you. 57.5. Okay, so I have cleaned all the dimensions as much as I can. I hope all the dimensions are clearly visible. You can just pause the screen right here and try to draw this geometry on your own. Okay, after completion, go to Revolve and select the sketch. Specify vector. I will be choosing x-axis here. Click OK. We have created this compressor rings here. Now we need to provide fillet on the edges of this geometry. So go to edge blend and give a radius of 5 mm and select all these edges. To zoom in and rotate the geometry to view all the lines. This line is not visible. I got this edge. Okay. Now I need to create fillet here. Select this edge. This one also. This one. It's showing some error. Let me unselect this. Has some problem. Okay, so let's leave that. Okay, so some edges are still left, the edges in between the rings. Go to edge blend again, select this edge and this one also. Okay, now it's complete. Click OK. Now we need to create blades on the face of this ring, so we need to first define the datum plane here. So for that let's go to sketch, select this face, click OK. Now select point and mark a point on the edge of this circle. Try to get the vertical relation with the coordinate system. I haven't got it, no problem. Go to geometry constraints, point on curve, select this point and y-axis, close. Okay, now it's vertical. Finish the sketch and go to datum plane and select the face of this ring and this point also. Okay, now select sketch and select this plane. One thing that you need to do is shift the origin to the edge of this first ring. This will shift the origin to the center of the first ring in this compressor. Now go to spline and draw a 3 control point spline here. The degree of the spline is 2. And go to rapid dimensions and define the coordinates. So this dimension is 165.2 mm. Now select second control point and origin and define the dimension as 179.6 mm. Okay. And the horizontal distance is 12.4 mm for the first control point. This is 9 mm. No need to define dimensions on the third control point. We need to define the coincident relation, this point and this point. Okay. Now the sketch is fully constrained. Now finish the sketch. Now we need to create a datum plane 83 mm offset from this datum plane. So finish the sketch, datum plane, select this plane and define the distance as 83 mm. Okay. Now again select this sketch for the sketching and shift the origin to the previous location. Okay. Again draw a spline with 3 control points. The degree of the spline is same as before, 2. Define the dimensions. This dimension is again 165.2 mm. Second control point is 181.2 mm in the -y direction. So the last control point is 195 mm below the x-axis. Now select horizontal method. This dimension is 17.3 mm. Select this second control point, origin 8.2 mm. The last one here is 10.4 mm. Close this geometry. Sketch is fully constrained. Now we go to surface and select through curves. Select your first curve and then add new set and second curve. Make sure these lines are in the same direction, otherwise the geometry is going to be skewed. We need to thicken these surfaces. Go to surface and select thicken and give an offset of 1 mm in each direction. You can also provide unite boolean feature with the first body. Otherwise you can unite the bodies later on as well, and pattern this geometry across the edge of the circle. Count and span. Count is 50 number of counts, and in the span of 360 degree. So we have created 50 copies of the geometry. Let's hide all these planes. Now we will repeat all these steps in the other two rings as well. So go to sketch, select the face of this ring. Okay. Now here, mark a point on the edge of the circle. And give a geometric constraint point and curve, this point and y-axis. Finish the sketch and draw a datum plane. Click OK. Click sketch. Select this plane. Now again draw a spline with 3 control points and define the dimensions. Go to rapid dimension. This dimension is 17.28 mm. Second control point is 12.4 mm. This dimension should be 17.9 rather than 17.28. 17.9 mm. This dimension is 59.6 mm. Again, we are not defining the dimensions on the third control point because we need to provide a geometric constraint on that point. This dimension is 80.5. Close. Now give the geometric constraint coincident. Select this point and this point. Okay, close. Now again create a datum plane with the offset of 83 mm. Datum plane, select this plane, offset is 83 mm, create sketch, select this plane, and shift the origin. Okay. Select spline, draw a 3-point spline here, and define the dimensions. Go to rapid dimension, select this point, and origin. Measurement method is vertical. Define this dimension as 60.5 mm. Second dimension is 81.3 mm. The last one is 100.4 mm. 100.4 mm. Yeah. Now select horizontal, first control point, origin, origin. This is 28.2 mm in the positive x direction. Second control point is 10.5 mm, again in positive x. This one is 14.81 in the negative x direction. There's a switch. Again, select surface through curves. Select this curve, add new set. Select this one also. Click OK. Now go to surface, thicken. Select this surface. Create 50 copies of this blade also. Select this feature, select the edge of the circle, create 50 copies. Okay. Now the last ring is left. Hide these planes also. Select sketch. Draw a point, okay, on the edge of the circle. Now define a vertical relation. So as I told you guys in the previous tutorial as well that I'm using NX10 and NX10 don't have a vertical relation, so I have to use point on curve only. Vertical constraint or point and curve, anyway. So here I have created another data plane and shifted the origin, and again draw another spline. Select rapid dimension. See this point. This is 9.45 mm. Second control point is 0 mm. This one is 15.5 mm in the negative x direction. This distance is 0 mm. It's 20.73. The last dimension is 40.1 mm. Is fully constrained. Now one more curve is left, so create another datum plane with the offset of 83 mm. Select the sketch for sketching. Okay. Draw another spline. Go to rapid dimension. Select this edge. This dimension is 0 mm. 20.2. Last point has a height of 40.2 mm below the x-axis. Okay, now select horizontal. Select first control point origin, 19.9 mm. This one is 2.4 mm. The last point is 24.9 mm in the negative x direction. So if your spline doesn't resemble like this, so you can just create a negative sign in front of the dimension. That will just change the side on which the dimension is. Your x direction and my x direction could differ a bit, so that's why. So we have here just pattern this geometry after thickening. So now we have created our geometry. Geometry is complete. Let's hide all these sketches and curves. So So we have created successfully a compressor ring, a set of compressor rings instead. This is a low pressure compressor. Let's modify the looks of the instrument. Let me choose a goldenish color. So this one, I will choose this one. Okay. Hit apply. Okay. So if you guys like this video, please hit the like button. If you want more such content, please subscribe to the channel. And I will see you guys in the next tutorial where I will be designing the high pressure compressor rings and the plates for this. Okay. So see you guys in the next tutorial.